In space, sound waves cannot travel because there are no air molecules to carry them. But space isn't completely silent. Using advanced instruments, scientists have recorded electromagnetic waves, plasma interactions, and other phenomena from space. These signals have been converted into sounds that we can hear. Now, you will hear those sounds. This sound was recorded by SOHO and represents the vibrations of the sun's surface. These vibrations are caused by waves of plasma moving across the sun's outer layers. Messenger recorded faint magnetic interactions around Mercury. These signals are created as the solar wind hits Mercury's weak magnetic field. This sound is based on radar data from the Magellan spacecraft, reflecting its interaction with Venus's rocky surface during mapping. This sound was captured within Earth's auroral zone, representing the movement of charged particles in the upper atmosphere. It's the faint hum of our planet's auroras. MAVEN recorded this sound in the upper atmosphere of Mars. It reflects plasma waves created by the interaction between the solar wind and the planet's atmosphere. This sound is from plasma waves in Jupiter's massive magnetosphere, recorded by the Galileo spacecraft. The strong magnetic field generates intense radio waves. The Cassini spacecraft recorded these sounds of radio emissions from Saturn. They are linked to its auroras and intense electrical activity at the poles. Voyager 2 captured this sound near Uranus. It reflects the activity in the planet's magnetic field and the interaction with solar wind particles. This sound was recorded by Voyager 2 as it passed Neptune. It comes from charged particles interacting with Neptune's magnetic field, creating plasma waves. Recorded by New Horizons during its flyby, this sound reflects plasma interactions near Pluto, a distant and icy world at the edge of our solar system. This sound comes from acoustic waves near a supermassive black hole. These waves are created by matter being pulled in and heated as it spirals toward the event horizon. The rhythmic beeping sound comes from a pulsar, a rapidly spinning neutron star. Each pulse represents a rotation of the star emitting radio waves toward Earth. The Venera probes recorded this sound as they descended through Venus's dense atmosphere. It represents the turbulence caused by strong winds and immense pressure. This sound comes from winds blowing across the surface of Mars, recorded by the InSight lander. The vibrations were picked up by its highly sensitive seismometer. This sound was recorded by the Huygens probe during its descent to Titan. It captures the movement of slow winds through the moon's thick nitrogen-rich atmosphere. The Galileo spacecraft recorded plasma waves in Jupiter's ionosphere. These signals are created by charged particles in the planet's upper atmosphere. This sound comes from Earth's magnetic field deflecting solar wind. It represents the protective barrier shielding our planet from harmful space radiation. This sound is based on light data from the Orion Nebula, a star-forming region. It captures the intense activity of gas and dust clouds illuminated by young stars. As Voyager 1 crossed into interstellar space, it detected plasma waves from charged particles. These signals mark the transition beyond the influence of the sun. The Pillars of Creation sound is derived from light data collected by Hubble. It represents the motion of gas and dust in these towering star-forming structures. Galileo recorded plasma waves near Callisto, one of Jupiter's moons. These waves come from the moon's weak interaction with Jupiter's strong magnetic field. New Horizons captured the sound near Charon, Pluto's largest moon. It reflects plasma interactions in the faint exosphere of this distant world. This sound comes from the light waves of the Cat's Eye Nebula. It reflects the layered structure of gas and dust expelled by a dying star.